Contrails of vapor trails are line-shaped clouds sometimes produced by aircraft engine exhaust, typically at aircraft cruise altitudes several miles above the Earth's surface. Contrails are composed primarily of water, in the form of ice crystals. The combination of water vapor in aircraft engine exhaust and the low ambient temperatures that often exist at these high altitudes allows the formation of the trails. Impurities in the jet exhaust from the fuel, including sulfur compounds, provide some of the particles that can serve as sites for water droplet growth in the exhaust, and, if water droplets form, they might freeze to form ice particles that compose a contrail. The formation can also be triggered by changes in air pressure in wingtip vortices or in the air over the entire wing surface. Depending on the temperature and humidity at the altitude the contrails form, they may be visible for only a few seconds or minutes, or may persist for hours and spread to be several miles wide, eventually resembling natural cirrus or altocumulus clouds. Persistent contrails are of particular interest to scientists because they increase the cloudiness of the atmosphere. The resulting cloud forms may resemble cirrus, cirrocumulus, or cirrostratus, and are sometimes called cirrus aviaticus. Persistent spreading contrails are thought by some, without overwhelming scientific proof, to have a significant effect on global climate. Persistent contrails are sometimes called chemtrails in reference to the conspiracy theory regarding the undisclosed spraying of chemical or biological agents by various high-flying aircraft. Condensation from engine exhaust. The main products of hydrocarbon fuel combustion are carbon dioxide and water vapor. At high altitudes this water vapor emerges into a cold environment, and the local increase in water vapor can raise the relative humidity of the air past saturation point. The vapor then condenses into tiny water droplets which freeze if the temperature is low enough. These millions of tiny water droplets and/or ice crystals form the contrails. The time taken for the vapor to cool enough to condense accounts for the contrail forming some way behind the aircraft's engines. At high altitudes, supercooled water vapor requires a trigger to encourage deposition or condensation. The exhaust particles in the aircraft's exhaust act as this trigger, causing the trapped vapor to condense rapidly. Exhaust contrails usually form at high altitudes, usually above 8,000 meters, where the air temperature is below -36.5 degrees Celsius. They can also form closer to the ground when the air is very cold and has enough moisture. Condensation from decreases in pressure. As a wing generates lift, it causes a vortex to form at each wingtip, and sometimes also at the tip of each wing flap. These wingtip vortices persist in the atmosphere long after the aircraft has passed. The reduction in pressure and temperature across each vortex can cause water to condense and make the cores of the wingtip vortices visible. This effect is more common on humid days. Wingtip vortices can sometimes be seen behind the wing flaps of airliners during takeoff and landing, and during landing of the Space Shuttle. The visible cores of wingtip vortices contrast with the other major type of contrails, which are caused by the combustion of fuel. Contrails produced from jet engine exhaust are seen at high altitude, directly behind each engine. By contrast, the visible cores of wingtip vortices are usually seen only at low altitude, where the aircraft is traveling slowly after takeoff or before landing, and where the ambient humidity is higher. They trail behind the wingtips and wing flaps rather than behind the engines. During high-thrust settings, the fan blades at the intake of a turbofan engine reach transonic speeds, causing a sudden drop in air pressure. This creates the condensation fog which is often observed by air travelers during takeoff. For more information see the Prandtl-Glaude singularity effect. The tips of rotating surfaces sometimes produce visible contrails. Contrails and climate. Contrails, by affecting the Earth's radiation balance, act as a radiative forcing. Studies have found that contrails trap outgoing long-wave radiation emitted by the Earth and atmosphere at a greater rate than they reflect incoming solar radiation. NASA conducted a great deal of detailed research on atmospheric and climatological effects of contrails, including effects on ozone, ice crystal formation, and particle composition. During the atmospheric effects of aviation project, global radiative forcing has been calculated from the reanalysis data, climatological models and radiative transfer codes. It is estimated to amount to 0.012 W per square meter for 2005, with an uncertainty range of 0.005 to 0.026 W per square meter, and with a low level of scientific understanding. Therefore, the overall net effect of contrails is positive, i.e. warming effect. However, the effect varies daily and annually, and overall the magnitude of the forcing is not well known. Globally, values range from 3.5 milliwatts per square meter to 17 milliwatts per square meter. Other studies have determined that night flights are mostly responsible for the warming effect. While accounting for only 25% of daily air traffic, they contribute 60 to 80% of contrail radiative forcing. Similarly, winter flights account for only 22% of annual air traffic, but contribute half of the annual mean radiative forcing. A 2015 study found that artificial cloudiness caused by contrail outbreaks reduce the difference between daytime and nighttime temperatures. The former are decreased and the latter are increased, in comparison to temperatures the day before and the day after such outbreaks. On days with outbreaks, the day-night temperature difference was diminished by about 6 degrees Fahrenheit in the U.S. South and 5 degrees Fahrenheit in the Midwest. September 11, 2001, Climate Impact Study. The grounding of planes for 3 days in the United States after September 11, 2001, provided a rare opportunity for scientists to study the effects of contrails on climate forcing. Measurements showed that without contrails, the local diurnal temperature range was about 1 degree Celsius higher than immediately before. However, it has also been suggested that this was due to unusually clear weather during the period. Condensation trails have been suspected of causing regional-scale surface temperature changes for some time. Researcher David J. Travis, an atmospheric scientist at the University of Wisconsin-Whitewater, wrote in the science journal Nature that the effect of the change in aircraft contrail formation during the 3 days after the September 11 attacks was observed in surface temperature change, measured across over 4,000 reporting stations in the continental United States. Travis's research documented an anomalous increase in the average diurnal temperature change. The diurnal temperature range is the difference in the day's highs and lows at any weather reporting station. Travis observed a 1.8 degrees Celsius departure from the 2 adjacent 3-day periods to September 11 to 14. This increase was the largest recorded in 30 years, more than 2 standard deviations away from the mean DTR. The September 2001 air closures are deeply unusual in the modern world, but similar effects have provisionally been identified from Second World War records, when flying was more tightly controlled. A 2011 study of climate records in the vicinity of large groups of air bases found a case where contrails appeared to induce a statistically significant change in local climate, with a temperature variance around 0.8 degrees Celsius, suggesting that examination of historic weather data could help study these effects. Head-on contrails. A contrail from an airplane flying towards the observer can appear to be generated by an object moving vertically. On November 8, 2010 in California, a contrail of this type gained wide media attention as a mystery missile that could not be explained by U.S. military and aviation authorities, and its explanation as a contrail took more than 24 hours to become accepted by U.S. media and military institutions. Trails. Where an aircraft passes through a cloud, it can clear a path through it. This is known as a distrail. The plane's warm engine exhaust causes existing water droplets to evaporate, leaving a clear wake through an otherwise cloudy sky. Clouds form when invisible water vapor condenses into microscopic water droplets or into microscopic ice crystals. This may happen when air with a high proportion of gaseous water cools. A distrail forms when the heat of engine exhaust evaporates the liquid water droplets in a cloud, turning them back into invisible, gaseous water vapor. Gallery.